To find the distance d over which a signal can be seen in clearly foggy conditions, a railway engineer uses dimensional analysis and assumes the distance depends upon mass density rho, intensity, that is power by area, s of the light signal, and frequency is f. You find, okay. So density, okay. So d should be equal to rho to the power a, intensity s to the power b, and frequency to the power c. Okay, so now this distance is going to be in meter. Rho, it's kg per meter cube, so therefore kg m to the power minus 3 to the power a. Okay, s is power by area, so power is F into V by area meter square, so therefore this is Newton meter per second divided by meter square. It's gone. This is kg ms minus 2 into s minus 1 divided by m, so it's kg per second cube. This is s. Okay, and frequency is 1 by. So therefore we can write m is equal to kg m to the power minus 3 a into kg s to the power minus 3 b into frequency, which is s to the power minus 1 c. So therefore kg a plus b, m minus 3a, s minus 3b minus c. This is m is like this. So therefore we can clearly see that minus 3a is equal to 1. So therefore a is equal to minus 1 by 3. So the engineer finds that d is proportional to s to the power 1 by n. Okay, so now if you see s to the power b, so d is proportional to s to the power 1 by, okay, we have calculated a. So now since a plus b for kg, a plus b is going to be 0, so therefore a becomes 1 by 3. So d becomes, a plus b equal to 0, so b becomes 1 by 3. So d is proportional to s to the power 1 by 3, so therefore n value is 3. We need not calculate c because like we already have found out n, therefore